Picking up where the last one left off, we are going to start today, tonight, whenever, talking about the differences between weather and climate. And it's important to remember that while they are related, yes, that's true, and that weather, eventually enough of it makes up climate, they are not synonyms. Weather does not equal climate. Weather is what's happening outside right now. If it's raining, or if it's sunny, or if it's snowy, or whatever, that's weather. However, climate is the long-term, over years and years and years, 30 plus years of all this weather combined to give us an average. And so what we have to do is we look at, in this class we're going to keep it simple, variations in temperature and precipitation. If you go to study this for real, you'll understand that it's way more complicated than just that. But to keep it simple, we're going to look at widespread temperature and precipitation variations. And to understand that, let's talk about, where we are on the Earth, and no, not necessarily North Carolina, but you have to look at latitude and how close to the equator or how far away from the equator, closer to the poles that you are. Thinking back to astronomy, we know that the Earth is tilted at about 23.5 degrees, but regardless of that, we know that the equator pretty much gets constant sunlight, which means it's going to stay warm there year round. We also know that, maybe it stays summertime. The light is up in the poles for 6 months of the year and it's kind of dark for 6 months. Yeah, we can go to those extremes, but it still doesn't get direct sunlight. It's still never going to be very warm, even if it is sunny all day long. So what we have to then think about is classification and how we're going to classify and where we're going to put these different types of climates. Now, you've probably talked about this before, and you might remember it, you might not, and you've probably talked about biomes before, you might not, and we'll get to biomes eventually, but right now we're not quite getting to biomes and to that yet. We need to discuss air masses. And air masses then take warm water or cold water, or warm land or cold land, and it creates what's in the air above it. And if it's over land, we call it continental, and if it's over water, we call it maritime. And if it's warm, we call it tropical, and if it's cold, we call it polar. Now, we can mix up any of those four things into a bunch of different things. We can have MT, which is maritime tropical, or CT, which is continental tropical. And all that means is the moisture content, if it's, wet or dry, and if it's warm or cold, maybe it's maritime polar, formed up in the northern Atlantic or something like that. Really just mix and match, and you don't need to know the super specifics yet, but when we get to weather, you'll definitely need to know them then. So let's talk about those different base level of climates. Well, we can map all of this out into things called climatographs. And a climatograph is the average monthly temperature and precipitation of a given area. Now, I know that the one that I gave you looks like temperature and precipitation are related, and maybe in that area it happened to be, but they don't have to be related. The graphs, and we're going to work with these eventually, don't have to follow the same trend. So let's look at the first one, which is a tropical climate. Now, you might be thinking rainforest or near the equator, and you'd be exactly right. It's going to be maritime tropical, so it's going to be moist, wet air that's also warm because it's near the center of the globe. It's near the equator. It's near zero latitude. And it's going to have lots of rain, consistently high temperatures, and we're going to see this in places like South America or Indonesia or anywhere we think of having rainforest. Flipping that off a little bit, we have, not flipping off, you know what I'm saying, we have dry climates, and we can then think about it where it's dry, meaning obviously there's no precipitation, it's in the name, but it's still pretty warm. Think Sahara Desert. That's going to be a CT, a continental tropical air mass. So over land, continental, dry, tropical, it's still warm. Let's kind of go somewhere in between those two. Well, the first thing is going to be a mild climate, hence the name mild climate. It's going to be warmer in the winter and cooler in the summer. It might still get hot, it might still get cold, but we're not going to see the huge extremes like we would see in a continental climate, which we're getting ready to talk about. North Carolina is a mild climate, and some of you said it was humid subtropical, and you're right. That is a climate that is housed under the big umbrella that is mild climates. But also Italy. What do those two places have in common? We're kind of near water. A continental climate is like a mild climate, but taken more to the extremes. It's going to have hotter summers and colder winters. And we don't typically think of Canada as being warm, but there are days where Toronto is actually warmer than we are in North Carolina. However, we typically think of Canada being very cold, and it is. And because it's so far away from water, it's going to have those huge variations because, as we remember, hopefully, water is really good at regulating climate. When you're far away from it, you don't have that regulation happening. You get wider extremes. So finally, we can have polar or highland climates. And polar, in the name, it's the poles. It's consistently cold, very little precipitation. Typically, you'd think of it like snow or ice. And yes, the poles do have lots of ice going on. However, it doesn't snow a lot up there. Now, we might think about it because, we think about polar bears and they're often seen in snowy conditions. But the poles themselves don't get that much precipitation. But sometimes we see this like a baby version of it, I guess, if you want to think of it like that, in the highlands. And what does that mean? Well, it's on like the top of mountains, like the Andes in South America. It's really high up in elevation. Remember, we're still on the ground, so it's elevation, not altitude, but it resembles a polar climate. So it's going to be cold pretty consistently and not a lot of precipitation. And that's going to take us to natural climate changes. And leading into that, and of course we'll get more into that specifically in the next video, natural climate changes definitely do exist, and if people tell you that it doesn't, then they're wrong. But there's something that we need to remember in that natural climate changes exist, but they're not the reason that we're in the position that we are. Climate has always been changing. That's true, and people might say that, and there might be a little disingenuous when they say that, but it's true. It definitely has always been changing. However, natural climate change does not explain where we are now.